The Fibonacci sequence, in Agile estimating at least. Now, this session is for those of you who are estimating in points or are interested in estimating work in points. A point-based estimation system is simply assigning a numerical value to represent the estimated size of work. And we're talking about product backlog items. In a previous session, we talked about how you could use t-shirt sizes, small, medium, large, maybe even extra small and extra large. But what if you wanted to do something numerical? Well, the Fibonacci sequence has become the most popular numerically based estimation system for Agile teams. And Fibonacci discovered this in nature. You've all heard of this sequence. 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 5 equals 8, 5 plus 8 equals 13, etc. Now, Fibonacci wasn't the original to find this sequence. It was discussed in ancient India, but Leonardo Fibonacci is the person who made it famous. Why is that Fibonacci sequence intriguing to Agile teams? Well, there's a particular aspect of it that I find helpful, and that is this is a geometric scale. It is not a linear scale, which means that as you move further down the scale, there are larger and larger gaps in the numbers. So if my team is estimating a piece of work further down the scale, it's implying larger and larger gaps in confidence, gaps in clarity, maybe gaps in understanding, which is a good reason to keep our work items on the smaller end of the scale. Well, how far should you take this scale? How many values would be in our set of numbers available to us to estimate? Well, as you can see by the list that I have here, I like to stop at this made up number of 100. So as we go down the scale, 5 plus 8 equals 13. 8 plus 13 equals what? Well, we know that's 21. Why would I say 20? And then you can see I jumped to 40 and then up to 100 again. What happened to the precise measurements of Fibonacci? Well, that's exactly my point. The further you get down the scale, precision becomes more problematic. Does it really matter if the estimate is a 20 or a 21? Now, we can have those types of debates between a 3 and a 5, but between a 20 and a 21, the work is getting too large for that sense of precision. So I come up with these numbers like 20 and 40 to simply remind my teams, don't get caught up in a false sense of precision. But precision that doesn't really matter. We're looking for accuracy over precision. Accuracy is the odds of us being right. What are the odds of us being right that our estimate is around a 20? Well, it may be a fairly good level of confidence, but debating 2021, probably going to lose our sense of accuracy there, over focusing on precision. What's my 100? Well, I believe that we need to have some logical cap, some number beyond which would be unreasonable to even discuss. And I use the 100 to represent the reject. It's the class of estimation that should never be used for budgetary planning or for scheduling. The 100 is another way of saying reject, kick it back. It's too big for us to estimate. It needs to be broken down to smaller pieces. Now, some teams, instead of using 100, they'll use an infinity symbol to symbolically recognize this idea of stop, it's getting too large for that. And in a similar manner, there are some teams on the lower end who will come up with a half, starting with that number because they discover there are work items even smaller than a one, work items that don't warrant being called a one. And also, contrary to Fibonacci, some teams will even have a zero. A zero is a request that is effectively no effort. An example could be we get a request and we look at it and realize, oh, we already do this. All we have to do is flip a switch. It doesn't even require any testing. It's a configuration item. Not even worth estimating. Let's just do it right now. Don't even bring it into the sprint. Just flip that switch right now to help them out.